Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ukobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so we are still on question 4, organic reactions. It says the flow diagram below shows the preparation of different organic compounds from CH3, CH2, and CH3, right? X, Y, and Z represent the organic reactions. So we can tell that this one here is an alkane. And then if it's reacting with Br2 here, this is halogenation, which is the halogenation from substitution. So this is from an alkane to a haloalkane. Now, if we are to use this SSS, USA, and SUE, this is moving from an alkane, a saturated carbon, a saturated compound meant to say, and then all the way to a haloalkane, which is also a saturated compound. So this is telling you that we have a substitution reaction. But then now if it's moving from a saturated compound and then through reaction X, it is going to an alkene, which is unsaturated, then we know from saturated to unsaturated, that means reaction X here has to be an elimination. So note, we are still just analyzing here. This is a saturated compound, and then it goes to an alcohol, which we know an alcohol as well is saturated. So reaction Y as well has to be a substitution. And then we have compound Z now. This is coming from an alcohol, which is saturated, and it's going to an alkene, which is unsaturated. It's a double bond. So if it's moving from saturated to unsaturated, it is also elimination as well, right? So we have elimination here. Then 4.1 says, write down the type of reaction represented by reaction X, Y, and Z. So for X already we have analyzed it there. And then we know that this is elimination because it's moving from saturated compound to an unsaturated compound. Then Y, we are moving from a saturated compound to a saturated compound. That means this is a substitution reaction. Then Z, look at the arrows from the alcohol all the way to an alkene, from saturated to unsaturated, right? And then that one is elimination as well. Right. So make sure that you understand the terms. When we are talking about saturated, this is when we have single bonds between the carbon atoms. And then when we are talking about unsaturated, this is when we have, according to this, double bonds, right? So we know it's multiple bonds, but then according to our reactions here, because we know that we work with single bonds and double bonds, so it has to be the unsaturated one will have to be the one that forms a double bonds. So just like that, guys, you have all your marks here, all these 3 marks from identifying those reactions. Note that if they only say the type of reaction, you don't have to go deep into trying to be specific as to what type of elimination or substitution. It's only when they ask you what type of elimination reaction, that's when you can be specific as to what type of elimination reaction it is. But if they only just say type of reaction, your answer should be elimination, substitution, or addition. Right. Then 4.2, reaction X takes place in the presence of a strong base. Right. So reaction X takes place in the presence of a strong base. Now they say, write down the IUPAC name of compound A. The IUPAC name of compound A. Now, again, we know that we just have to look for that one structural formula or condensed structural formula in order to know these other compounds. So here we can see that we are given a condensed formula here containing 3 carbon atoms. So that means each and every compound here must maintain those 3 carbon atoms. But then remember, this is halogenation, and then it's a substitution reaction. That means we have to replace 1 hydrogen atom with a bromine. But according to Markovnikov rule, we know that that bromine there will have to attach to the second carbon. So the IUPAC name now will be 2-bromo since we know that that bromine will attach to the second carbon. So it will be 2-bromopropane. So this is what will happen if I have to draw a structural formula showing that. So the hydrogen that we're going to replace is a hydrogen from here. Because remember, according to Markovnikov rule, we must take the hydrogen from the carbon with less number of hydrogen atoms. So this has 3 hydrogen atoms. This carbon here has 3 hydrogen atoms. The only carbon with less number of hydrogen atoms is the second carbon, where we're going to take our hydrogen from and replace with the bromine. So hence we have 2-bromopropane, right? Hope that makes sense. Then 4.2.2 says now the balanced equation for reaction X using structural formulae. Then for compound X, we now have the compound A there, which we did help ourselves by just drawing the structural formula there. So this is what we're going to be having. And then we know that compound reaction X is an elimination reaction. So this will have to react it with sodium hydroxide. And then this will give us what? Since it's elimination, we know that we have to eliminate the bromine there. So to be more specific, this is a dehydrohalogenation reaction. So we eliminate the bromine, but then we cannot take the hydrogen from the same carbon there where we took the bromine. So we need to take the hydrogen from the other carbon, right? Then this is supposed to give us HCH here. And then the double bond obviously has to form between the 2 carbon atoms where I took the bromine and the hydrogen. So now we have it like that. But then note here, it is very important to show the byproduct. So the Na here will have to react with the bromine that was extracted out. And then the hydrogen here will have to react with the OH to form water. Right. So these are the 2 inorganic products that will form. And the major product that forms is this one here. And then just like that, you have your 5 marks. And then you can indicate that this happens under the presence of heat and concentrated sodium hydroxide. Right. Then now, 4.2.3 says the IUPAC name of the alkene produced. What is the IUPAC name of this alkene? Now, if we start numbering from this side here, closest to the disturbance, closest to the double bond, this is 1, 2, 3. So this becomes what? 1. This becomes prop 1 in instead. Prop 1 in, or you can just go it's propene. Prop 1 in or propene. Then 4.3 says state 2 differences in the reaction conditions of X and Y. In the reaction conditions of X and Y. So we know that here for X, this is what we call a dehydrohalogenation, which the reaction conditions for a dehydrohalogenation is that we must have what? A concentrated. So for X, let's mention that for X, we must have a concentrated strong base and heat. But then for reaction Y, which is a hydrolysis reaction, substitution, it's a hydrolysis reaction, we must have a dilute strong base. So the difference here is that for the elimination, we need concentrated strong base, but for the hydrolysis, we need dilute strong base and mild heat. So those are the differences in the reaction conditions of reaction X and Y. Now, compound B, they say 4.4. Compound B is a secondary alcohol define the term secondary alcohol. Define the term secondary alcohol. How do we define a secondary alcohol? Now, I'm going to say a secondary alcohol is an alcohol where the carbon with the hydroxyl group is bonded to two other carbon atoms. So that is a definition of a secondary alcohol. So basically, it's when you have something like this. Carbon there and a carbon there. So we might have hydrogen atoms like that. But then basically, if we can locate the carbon with the hydroxyl group, and then we see that the same carbon is bonded to two other carbons, that makes it a secondary alcohol. And that's how you were supposed to approach this question, guys, for a total of 15 marks. You know the rule, leave no marks to charity when it comes to organic chemistry, whether it's your question 2, question 3, or question 4. Make sure that you aim for 100%, because that's where you're going to get your marks from if you want to excel in that paper 2 physical sciences. So just make sure that you practice this topic. All that you need to do, guys, is study your notes and just go and apply your note into paper. So, guys, with all that being said, we've came to the end of the lesson. Please press the thumbs up button if you have enjoyed the lesson and then you have found it helpful. And then if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. And also, if you are watching the videos from Facebook, please like the page and follow the page. And most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.